Welcome to the WirelessHART, the best option for any 1 to 4 workshop on wireless sensor network technology selection for plants. My name is Jonas Birch, and I'm a Senior Director of Applied Technology at Emerson Automation Solutions. Today, I'm presenting on behalf of the Fieldcom Group. Imagine a digital plant, an intelligent plant that tells you when there is a non-uniform temperature profile in the furnace, or if somebody left the manual transfer valve open, which is supposed to be closed. Imagine the plant telling you if there's a leak or spill, or when somebody activates a safety shower, meaning they need help. Imagine the plant telling you it is time to schedule bearing replacement or the pump will fail. Or you need to inject more corrosion inhibitor to protect the piping because the feedstock is more corrosive. Imagine the plant telling you you need to schedule relief valve overhaul because the PRV is passing product to flare. Or there is fuel gas overconsumption due to fouling of heat transfer surfaces, so you need to clean. This is the vision for digital transformation and Industry 4.0. All this requires additional sensors, hundreds of sensors. It's not practical to wire all these sensors. You need wireless sensors and a wireless sensor network infrastructure. The right wireless sensor network technology is reliable, is fast when you need it, it's simple to commission, it's an international standard, so low risk of going obsolete. It can use the same intelligent device management software as wired instrumentation if you like. Has long battery life. You can use the same field communicator as wired instrumentation. Data integrates with your existing DCS, PLC, historian, and other software. You can centrally configure sensors. You can access advanced diagnostics like vibration spectrums. But wireless sensor network technologies are not the same. There are very significant differences between them. Only one of the technologies offer these benefits. Some technologies have none of these benefits. The wrong wireless sensor network technology is not reliable, requires a lot of costly infrastructure, is slow, needs special tool to commission in many steps, is a proprietary technology which has risks of obsolescence, cannot use intelligent device management software used for wired instrumentation, has short battery life. Every sensor manufacturer have their own sensor configuration and calibration tool and their own monitoring software. There is no Modbus or OPC to integrate with your existing DCS, PLC, historian, or other software. There is no centralized sensor configuration software. And you only get status, but no advanced diagnostics. For instance, no vibration spectrum. So be careful. You will have to live with these limitations, if you pick the wrong technology. The site IT team is not familiar with a plant full of steel or replacing batteries in sensors or Modbus or OPC, DCS, historian, or device management software, and not familiar with sensor configuration or vibration spectrums. So the INC team must therefore take the lead to guide in the sensor network selection. Now, one size does not fit all. Therefore, there are many wireless technologies with different characteristics to meet the different needs of various application areas. For home and office, we want low cost and high speed for streaming video, so we use a wireless local area network or wireless LAN like Wi-Fi. In smart cities and agriculture, they need low cost and long range, for the wide areas. So they use wireless wide area network or wireless WAN. But in a plant, we need all of the attributes we just spoke about, so we need an industrial wireless sensor network technology, which is different from the others. So against that background, we will cover selection criteria for wireless sensor network for the plant. The requirements come out of the NAMUR NA124 recommendation. NAMUR is an organization of process automation users. So these are real end user requirements. So for each requirement, I will provide a little bit of background on why it's important, explain the limitations of non-industrial technologies. That is the reason you should not use non-industrial networks in plants. And lastly, I will explain how an industrial wireless sensor network tackles the issue. That is the reason you should use an industrial grade network in plants. So note again that range is not a requirement, okay? And I will explain why. But first, let's see where wireless sensor networks are used in a plant. Wireless sensor update period is usually set to 1 minute or longer to conserve battery life. This is too long for functional safety or process control. Therefore, we will not be talking about wireless sensors for functional safety or process control. Wireless sensors are mostly used to automate data collection for reliability, sustainability, and productivity. The first requirement is availability and reliability, because this is probably the most important. You need greater than 99% reliability for the wireless sensor network in your plant to make sure the data is there when users need it. This number is not stated in NAMUR NE 1 to 4, but based on experience, 99% is necessary. Most technologies do not state any reliability. There's no commitment. This is so because the reliability of most technologies in a plant environment is very much lower than 99%. A plant is a challenging environment for wireless because radio frequency or RF signals cannot penetrate steel. And a plant is full of steel, including metal furnaces and storage tanks, the size of multi-story buildings. Moreover, there is a constantly changing RF environment in the plant as heavy vehicles move around and scaffolding goes up, causing radio propagation. That is, a wireless sensor network can be made to work initially, but as the RF environment changes over time, with the wrong technology, part of it may suddenly fail. Okay? So what I'm explaining here is basically about 10 to 14 of the different requirements in the NAMUR NE 1 to 4 specification. Okay, so reliability is really the first requirement in that specification, right? Anyway, so most wireless sensor network technologies use star topology, meaning the gateway communicates directly with every sensor point to point. Because the radio waves cannot penetrate steel, star topology radio communication requires a clear line of sight between the gateway and all sensors. That is, it must be possible to see the gateway from every sensor location for it to work. For open spaces like homes and offices, on city streets and in crop fields, this works fine. Star topology can work. However, in a plant, the line of sight is limited to perhaps 50 meters or less. So you can't see the gateway from the location of most sensors due to all of the metal obstructions. And therefore, radio waves also cannot reliably reach the sensor. Thus, star topology is not suitable for a plant full of steel. Installing the sensors where there are no structures or far above the ground is not practical. So due to these limitations, many more gateways are required, which would be very costly and disruptive to deploy in an existing plant. So be careful. And don't count on wireless signals to, bounce around metal objects, because once the object moves, communication will fail. This explains why star topology solutions do not state reliability in a plant full of steel. Again, be careful. And when a weak spot is identified in a star topology, an additional gateway and an associated cabling must be deployed. So once again, be careful. Some wireless sensor network technologies use star topology, but with a backbone to create many subnetworks, each with an intermediate backbone router. This requires a backbone network and power in the hazardous area, a complex infrastructure which again would be very costly and disruptive to deploy in an existing plant. So be careful. Most sensors in the plant are installed very low, close to the ground. Therefore, they are obstructed by multiple stories of metal also from above. So even a gateway mounted high up on a mast cannot connect to the ground level sensors or sensors behind a tall furnace or a column. Moreover, with the antenna in an elevated location, lightning-related risks increase. Sure, some sensors are installed high, but you can't have one wireless sensor network for those and another technology for all other sensors. You want a single network for all wireless sensors, so be careful. WirelessHART solves this using mesh topology. A sensor which does not see the gateway directly instead communicates with a neighboring sensor which relays the communication to the next sensor and so on in up to 7 hops or more until it reaches the gateway. The data gets routed around metal obstacles. A plant full of steel is not a problem for the WirelessHART technology. If there's a weak spot in the mesh topology, simply drop in a repeater. No need to install an additional gateway or backbone networking or power cabling. And each sensor doesn't just talk to just one neighboring sensor, it talks to many. So this forms a mesh of connection between sensors with multiple paths from each sensor to the gateway. That is data path redundancy, okay? And this is key to data availability and reliability. Right. You don't have to manually configure the communication paths between sensors. WirelessHART is self-organizing. So the mesh network is formed automatically when the gateway is turned on. Moreover, the self-organizing mesh topology adapts dynamically. If a sensor is moved, removed, runs out of battery, fails, or if an obstruction like a container arrives, blocking the RF signal, the system dynamically chooses one of the other paths, rerouting the data. This is how wireless achieves 99% reliability, even in a plant where the steel obstacles are moved around. But it's important to follow the WirelessHART design installation rules. The more sensors there are in a mesh network, the more possible paths there are between these sensors, and therefore the more robust the mesh network becomes. That is, because WirelessHART network is shared between many kinds of sensors for various use cases, you get a strong mesh of connections. Other wireless sensor network technologies without mesh topology or which are not self-organizing cannot achieve the same reliability. Okay, next, range. The most interesting fact is that NE124, the NAMUR standard or NAMUR recommendation, does not specify range from sensor to gateway as a requirement because it doesn't make sense in a plant full of steel. Since radio does not penetrate steel, there is no long range or wide areas in a plant. No wireless technology transmits through steel. It's physics. Therefore, the real range of wireless in a plant is only as far as the next metal obstruction. Range of a mile or more in open space has no meaning in a plant. So don't design your wireless sensor networking thinking a star topology with a 1 kilometer range will cover the whole plant. It won't. Anyway, point-to-point topology is only a single hop. Some wireless sensor network mesh topologies are able to do 2 to 4 hops, but that must be manually configured. This is not sufficient to go around large obstacles, so be careful. Multiple hops between WirelessHART sensors add up from sensor to sensor, totaling long distance or greater depth from sensor to gateway, even in a plant full of steel. So when comparing wireless sensor network technologies, ask not what is the maximum range from gateway to sensor. Instead, ask what is the depth, the maximum number of hops in one communication path. WirelessHART can do 7 hops deep or more. This capability allows WirelessHART to reach sensors deeper inside the plant units than other technologies can. As a result, the multi-hop capability gives WirelessHART the longest effective range and greatest coverage in a plant. Next requirement is real-time performance. WirelessHART sensors are mostly used in non-process applications, which are not time-critical, such as eliminating inspection and manual data collection. For these applications, an update period of 1 minute or 1 hour or even 1 day are enough. But in every plant, there are a few use cases that require faster update periods, such as 1 or a few seconds. Many other wireless sensor network technologies only support update period of a minute or longer, meaning there are some applications they cannot handle. So you must wire those sensors instead, which is costlier and more disruptive. So be careful. WirelessHART solves this with real-time capability with update periods of 1 second in applicable sensor types. So if the use case really requires such a fast update period, it is possible with WirelessHART. Having said that, select the update period thoughtfully. Do not select unnecessarily fast update period because it will drain the battery sooner. This is true for any wireless sensor network technology. Most wireless sensors are set to 1 minute update period to enjoy multi-year battery life. Vibration may be set to 1 hour. Okay. Also, upload of large data sets like vibration spectrum or waveform should also be done thoughtfully. As an example, Emerson worked with Chevron Oronite on their Singapore manufacturing plant 4.0. Work in the plant has been transformed over a few years and continues today. You can watch the video another time. As a result, they have made improvements in all operational areas like reduced downtime, lower maintenance costs, lower steam consumption, no incidents, and no loss of containment. Wireless sensor network technologies have similar security mechanisms. The difference is mostly in the ease of commissioning sensors. So wireless sensor network technologies use security mechanisms like those used for Wi-Fi. This includes authentication, which means for the sensor to join the network, it must first be provisioned, meaning configured with the network identifier, like Wi-Fi SSID, and the secret key, like a password. To make this provisioning easy and secure, this configuration cannot be done over the wireless network. The network ID and join key are configured out of band, meaning by other means. This is like set up using the wired console port on a Wi-Fi router. For several wireless sensor network technologies, the commissioning process to configure the network ID and key is very time-consuming, involving multiple steps and special tools. Even for sensors using the same technology, the tools and procedures differ from one sensor manufacturer to the next. For the initial installation, the system vendor will do this for you, but for future addition and replacement, you must do it yourself. So it's important this is easy, so be careful. WirelessHART solves this by using the same familiar HART field communicator or HART modem used for 4 to 20 milliamp instruments, which the plant already has. Often many sets. Instrument technicians are already familiar with these HART tools. The result is sensors easy to commission with security credentials. Other wireless sensor network technologies cannot use these familiar tools. Multi-vendor interoperability and standards. There are risks associated with proprietary technologies. For instance, non-backwards compatible changes to the technology forcing upgrades or changes to subscription models or license agreement and fees that turn sensor manufacturers off, ultimately affecting product and spare part availability as well as their cost. There are wireless sensor network technologies which are not an IEEE and IEC standard. Such technology is owned by a single company. It's proprietary technology. They license their technology to multiple sensor manufacturers, but ultimately the technology is controlled by a single company. It may be fronted by a trade alliance or many manufacturers using the technology in their products that can be used together. So it looks like a standard, but nevertheless, the technology is owned and controlled. Anyway, the technology could suddenly change, forcing extensive upgrades. So be careful. WirelessHART is supported by multiple vendors. This means you can buy WirelessHART products from multiple vendors and they will work together, called interoperability. Over and above interoperability, WirelessHART has universal and common practice commands used by all vendors, meaning you can also replace a failed sensor with a sensor from another vendor and it will work without system reconfiguration, called interchangeability. Over and above this, WirelessHART is an international standard, so it's not controlled by a single vendor. So the technology, the licenses, and the fees cannot suddenly change. Standardization dramatically reduces the risks associated of the technology. This is why I&C engineers specify IEC standards for all electrical and electronic equipment, including telecommunications, not just wireless sensor networks. Since there are technologies available that are an IEC standard, do not invest in other technologies which are not an IEC standard. Integration with intelligent device management system is important once you have lots of sensors. Just like wired sensors, wireless sensors need to be configured for the use case. You may need to monitor the self-diagnostics in the sensors, and from time to time, sensors may need calibration. Most wireless sensor network technologies do not have a common backhaul network application protocol for sensor configuration and advanced diagnostics data. Therefore, these sensors cannot be integrated into the plant's existing intelligent device management or IDM software. Note that even if you could map additional sensor data to Modbus or OPC to bring it into software, it would be impractical to do it and maintain it for all the information in all sensors. Other technologies have no solutions for centrally configuring sensors from multiple vendors. So be careful. WirelessHART solves this with the HART IP application protocol over Ethernet. HART IP is used for the backhaul network to bring sensor configuration and advanced diagnostics data into the plant's existing IDM software without any data mapping, thus saving time. HART IP preserves the message format and data structures for all information in the sensors. This is critical to make EDDL and FDI work. That is transparent integration. That means that all kinds of WirelessHART sensors from multiple vendors can be configured and commissioned from the same single software. The result is a common look and feel across all sensors. So they work the same way with very consistent procedures and therefore easy to use. WirelessHART sensors can be managed from the same IDM software used for the plant's existing HART and field bus, as well as future Ethernet APL instrumentation. Even IDM software based on FTT DTM can be used to manage WirelessHART sensors by installing the DTMs for the gateway and sensors. Other technologies cannot achieve the same result because they either don't support EDDL or FDI, or they don't have standard backhaul protocol like WirelessHART, preserving the message format and data types for the configuration and diagnostics information. Battery life. The battery life depends on the type of sensor and selected update period. Faster update period means shorter battery life. And some types of sensors consume more power than others and therefore result in shorter battery life. The wireless sensor network technologies have different battery life, so it's important to select technology carefully. Most wireless sensor network technologies have a battery life of only a few years, even with update periods of several minutes or even once a day. This means frequent battery replacement. Taking the cost of erecting scaffolding to access a sensor into account, the cost of battery replacement is higher than the price of the battery itself. A low-price sensor, even with a low-price off-the-shelf battery, but with short battery life, has higher total cost of ownership. So be careful. WirelessHART solves this with time-synchronized publisher-subscriber or pub-sub communication. Every sensor has an internal clock and measures on a precise schedule or interval set depending on the application. For instance, a corrosion sensor may only need to measure and publish the data twice a day. A vibration sensor once an hour, a steam trap sensor once a minute, but a flow sensor once a second, or anywhere in between. The sensor is in fact sleeping most of the time, thus conserving battery. The sensor wakes up briefly to make a measurement, then goes back to sleep again. As a result, WirelessHART can achieve 5 to 10 year battery life for sensors. So you seldom have to replace the battery. This means lower total cost of ownership. Many other wireless sensor network technologies are not time synchronized and therefore have shorter battery life. Let's look at portable tools for the workshop workbench and for field work, and then integration of sensors and gateways into existing control systems. You must be able to set up the wireless sensors on the bench in the instrument shop. This may include sensor type selection for a temperature transmitter or a tank height setting for a level transmitter, and to function test before installing it in the field. And you must be able to calibrate the sensor in the field or on the bench using a portable calibrator. Since there is no wireless sensor network in the instrument shop, there must be an easy way to do this by other means. For several wireless sensor network technologies, there is no common way for bench or field configuration and calibration. That is, even for the same technology, manufacturers have different ways of configuring the sensor on the bench before it is brought into the field. This means different specialized tools for each vendor. One requires a laptop with infrared adapter, another USB cable, a third using NFC, and a fourth from the local operator interface on the sensor. So managing a variety of portable tools in such a heterogeneous environment will cause delays, and the system could even fall into disuse. Direct interface of a portable calibrator is not supported at all, so be careful. Some sensors cannot be calibrated or trimmed to correct for long-term drift. Once no longer accurate, you must throw away and buy a new one. Again, be careful. WirelessHART solves this with a wired HART console port. The HART tools almost all plants have today can be connected to this console port. HART field communicators, HART modems for laptops, and portable calibrators. This is ideal for configuration, function check, and calibration on the workbench or in the field. Because it's the same portable tools used for all wireless HART sensors, regardless of manufacturer, and the same familiar tools instrument technicians are already using for wired instrumentation. The procedures for wireless HART sensors are almost the same as for the 4 to 20 milliamp HART sensors. Calibrators don't support other wireless sensors. Digital transformation of reliability, sustainability, safety, and production work practices as part of Industry 4.0 require all kinds of advanced sensors. The plant will have wireless sensors from multiple manufacturers. Wireless sensors and apps cannot be isolated islands of automation. Sensors and apps must integrate with existing automation, such as the plant historian or control system. Many wireless sensor network technologies were designed for non-industrial applications like smart city or smart grid or agriculture. Such technologies don't define a standard application protocol with a common message format or common data types. Because of this, the gateway does not convert to Modbus or OPC for sensor measurement data. Therefore, sensor data does not integrate with applications like the existing plant historian or control system. This in turn means it becomes hard to put that data to good use, so be careful. Other wireless sensor network solutions offered by vendors often tend to be a single use case. So even with the same technology, you end up with multiple heterogeneous systems, with one software to monitor pressure from one vendor, another for the temperature sensors from another vendor, a third for level, and so on. So this mix of software makes the data harder to use, so may fall into disuse. So be careful. WirelessHART solves this by using the standard HART application protocol, which has a common message format and common data types for all WirelessHART sensors, regardless of manufacturer and sensor type. This enables WirelessHART gateways to convert standard data from a mix of sensors from multiple vendors to common industrial protocols such as Modbus, Ethernet IP, and OPC for integration with existing systems. As a result, data can be brought together into applications like the plant historian or control system without custom programming or scripting. From there, it goes into analytics, dashboards, reports, notifications. Many other wireless sensor network technologies lack standard application protocol and therefore do not integrate with existing automation systems. As an example, Emerson worked with Solvay Specialty Chemicals. So work in the plant has been transformed over a few years and continues today. You can read the article later. As a result, they have made improvements in all operational areas, reduced downtime, lower maintenance cost, lower steam consumption, and reduced off-spec product. Think big, beyond initial deployment of the first use case. The first use case will need only one type of sensor and one app. Another wireless sensor technology may be able to do the job for that one use case, but there are dozens of use cases in a plant, and as they are introduced one by one, the wrong technology will soon show its limitations when you want to deploy a solution to the next use case, which is more demanding, requiring a feature not supported. So you must think long-term. Now, configuration management. You may need to check or change the configuration of sensors, such as changing sensor type, engineering unit, and travel type, etc. You may need to restore configuration into a replacement sensor. But some wireless sensor network technologies only transmit measurement and status. There is no communication of configuration data to or from the sensor. That is, you cannot centrally check or change sensor configuration. You must go to the field to check or change sensor configuration locally at the sensor. This is impractical, particularly for large number of sensors or offshore. So be careful. WirelessHART solves this as sensor configuration is also communicated by request response or client-server communication as a non-real-time second channel. So you can read and write data such as sensor configuration on demand. As a result, this enables you to centrally check and change configuration. Existing IDM software centrally stores the configuration of all instrumentation, including wireless sensors. So the sensor configuration can easily be downloaded into a new sensor at the click of a button when an old sensor is replaced. Status and advanced sensor diagnostics. Sensors are installed in the harsh plant environment with extreme temperatures, moisture, dust, and chemicals. Many sensors are in direct contact with process, extreme pressures and temperatures, abrasive, corrosive, and subject to vibration. Sensors need self-diagnostics to detect and, where possible, predict sensor failure. The health of a mix of wireless sensors from multiple vendors must be monitored. As explained, with most wireless sensor network technologies, you end up with multiple heterogeneous systems with the software for each sensor vendor. Each sensor vendor's software displaying sensor status differently. Different icons, color coding, and terminology for the severity of sensor problems. This inconsistency among vendors makes sensors and software for such technologies harder to use, both for device diagnostics, alarm management, and prioritization for maintenance scheduling. So be careful. And some technologies only transmit measurement and status. There's no communication of advanced diagnostics data. That is, you cannot see detailed information like vibration spectrum or waveform because the information is not communicated. Again, be careful. WirelessHART solves this by supporting the NAMUR NE107 recommendation for 4 standard status signals. Sensor health is mapped to these 4 status signals. As a result, status display becomes consistent across vendors and sensor types, making service and maintenance easy. Many ISC engineers are already familiar with the NE107 status symbols, so they will welcome this. Additionally, WirelessHART provides advanced diagnostics communicated by request response or client-server communication as a non-real-time, second channel. This enables you to centrally analyze advanced diagnostics such as retrieving spectrum and waveform from a vibration transmitter. Many other technologies do not support communication for ad hoc reading of large data sets, so they cannot display advanced diagnostics. As another example, Emerson worked with Denka Chemicals. Work in the plant has been transformed over a few years and continues today. You can watch the video another time. As a result, they have made improvements in many operational areas like reduced downtime, lower maintenance cost, and 7% lower steam consumption. Conformance testing. To solve all the use cases in a plant, you need wireless sensors from multiple vendors to be able to join the common wireless sensor network. It must be possible to identify, configure, and calibrate the sensor, and to get the measured variables and self-diagnostic status regardless of vendor. That is, the sensor must comply with the many details in the technology specification. So WirelessHART solves this by conformance testing and registration by the independent Fieldcom Group organization. Products which pass the test are given a test certificate, which gives a level of reassurance the product will work well on wireless sensor network. As a result, you get peace of mind Other technologies which do not have independent testing do not provide such reassurance. Okay, to summarize. The recommendation is to use WirelessHART because WirelessHART has many features that makes it the best wireless sensor network technology for plants. The self-organizing mesh topology with 7 hops or more, the HART console port, it's an ISE standard, the HART IP backhaul application protocol for IDM software, EDDL and FDI, the time synchronized pub-sub communication and sleep mode, standard message and data formats converting to Modbus and OPC, plus client-server communication of sensor configuration and advanced diagnostics like vibration spectra. No other technology have all these features and therefore cannot achieve the same result as WirelessHART. That is, the WirelessHART technology is the most reliable, can be fast when you need it to, is the easiest to commission, is an international standard, so low risk. You can use the same IDM software as for wired instrumentation if you like, has long battery life. You can use the same field communicator as for wired instruments. Data integrates with your existing DCS, PLC, historian, and other software. You can centrally configure sensors, and you can access advanced diagnostics like calibration spectrums. Other wireless sensor network technologies cannot achieve the same result. That concludes the presentation parts, okay? Let's see if there are any questions. And by the way, here are my contact details so we can connect. And one question is, has NAMUR tested WirelessHART? The answer is yes. They tested WirelessHART back in 2009. It was actually tested by BASF in their Ludwigshafen plant. Can I mix update times in the same network? Yeah, you can. You can have like 1 second or a few seconds and 1 minute or a few minutes or 1 hour, all in the same network at the same time, in a mix of devices. What ISE standard is it? Well, it's ISE 62591. Yeah? What suppliers sell WirelessHART sensors? Well, Emerson, obviously, but also like, Siemens, SKF, United Electric Controls, Phoenix Contact, Peppel and Folks, Anderson Hauser, Armstrong, and ABB, and several others. How can I replace battery in a hazardous area? Okay, so the battery actually comes like as a power module, and the power module is intrinsically safe, and since it's intrinsically safe, you can replace that module in the hazardous area, so you don't need to bring the sensor out of the plant. You can replace the battery in the plant. Yeah. Which frequency is used? Okay, it is 2.4 gigahertz, so-called ISM band, using standard IEEE 802.15.4 radio. Can I have the slides? Yeah. It should be on the Akema site where you joined this session. If not, yeah, you can email me on this contact details here. You can scan my QR code. Is ISA 100 another wireless sensor network that meets all of the mentioned requirements? Well, ISA 100 is another sensor network, but it does not meet all of these requirements. It does not have the same characteristics as WirelessHART. For instance, it cannot do meshing, with 7 hops, only limited to 2 to 4 hops. It cannot, it's not self-organizing. It doesn't have a standard backhaul like HART IP, for instance. Okay, so these are some differences that come to mind. Okay, so that's really why WirelessHART is really truly a unique technology. There's another question: is WirelessHART compatible with the NAMUR open architecture? Well, WirelessHART does fit into the NAMUR open architecture. I mean, it can be on the core process control side, the CPC side, that's possible. But most of all, I think WirelessHART fits on the measurement and optimization, the M&O side of things, the ping sliver, So yes, WirelessHART definitely fits nicely into the NAMUR open architecture. Okay, how many sensors can one gateway have? Well, it really depends on the vendor and the model of gateway. I have seen gateways supporting 100 devices, 200 devices, and maybe even more, okay? So each vendor have, different specs for number of sensors or number of devices they support. Okay, here's another question. If I place update wait 5 minutes, does measurement also take place every 5 minutes, or measurement is real time? Yeah, no. So if you put a 5-minute update period, that means that the sensor sleeps for 5 minutes, then wakes up and makes a measurement and then transmits that measurement, okay? So it doesn't measure in between. There's a very simple reason for that. The sensor usually consumes more battery than the radio, okay? So if you make the measurement, you might as well transmit it. Yeah? Two overlapping WirelessHART networks can cause interference on each other. No, because like I mentioned, WirelessHART is using the IEEE 802.15.4 standards, So just like in one room, you can have multiple Wi-Fi networks, you can also have multiple WirelessHART network, and you can have WirelessHART and Wi-Fi and the Bluetooth all at the same time, not a problem. So what is the value available on instrument display at sleeping time? Okay, so that's a good question. So for example, transmitters that have an LCD display, they normally turn off that display when they go to sleep. However, an interesting option is, for instance, it's an Emerson product, it's a wireless pressure gauge that actually has a needle dial, just like a traditional pressure gauge, So that one actually, the needle still indicates the correct pressure while the sensor is sleeping. But I mean, the whole idea with wireless is that you should not have to go out and look at the transmitter, right? The transmitter might sit very high up, or it might be very far below or under the grated flooring. The beauty of wireless is that you don't go there. It's operator doesn't go to the data comes to the operator, okay? What is the difference between NE107 and NE124? Okay, so NAMUR, okay, is an organization of end users in the process industries, right? And they have nearly 200 specifications, okay? So NE107, that is the specification that defines these 4 condensed status, okay? So, a transmitter can have, dozens of different kinds of diagnostics, but to make the high-level display to an instrument technician or an operator easy, these are basically condensed into these 4 simple symbols, okay? So that's what the NE107 standard does. And these standard signals, they are used for all kinds of instruments. It doesn't matter if it's WirelessHART or 4 to 20 milliamp HART or foundation field bus or even Profibus. All of them use the same 4 signals, for consistency. So it becomes very easy to use. However, all of the other requirements that I spoke about today, so let me go to the beginning to this slide. So these requirements here, I think about 14 requirements, which are very specific to to wireless. Okay, that's what goes into the NE124 recommendation. Okay, so that's the difference. Huh? Are there any biopharmaceutical facility commercially staged which are using wireless sensors HART for validated systems? Well, I'm not sure if it's used in the validated process itself. May or may not be. I can't swear to that. I know there's a lot of pharmaceutical plants that use wireless, okay? I think they use it a lot definitely in the monitoring of the health of the the air handling units and that sort of thing, And I have also seen it to automate, some of the manual data collection, okay? In pharmaceutical, we want to eliminate paperwork as much as possible in manual data collections, so wireless sensors are certainly used for that, but do send me a mail and I will get you in touch with the pharmaceutical experts in the company, okay? Due to cost limitation, would be recommended to use other cheaper W sensor networks given that integration with existing software is possible, okay? So there are two things here, okay? There are a lot of cheaper wireless sensor networks. However, in order to integrate into existing software, for instance, they don't automatically convert into OPC or Modbus, So now you would need to have a system integrator to write scripts, etc., to make that happen, okay? So at the end of the day, that kind of solution does not become cheaper, because the additional work to set it up and then maintain it throughout the life of the system. So I wouldn't go that way, okay? Secondly, if it doesn't have mesh topology, then it's not going to be reliable, in a plant full of steel, okay? So then that becomes a point of frustration for the end user of the data. Once they become reliant on the data, if that data is not reliable, there will be a lot of frustration and gnashing of teeth, okay? So still, that's why WirelessHART technology has really become the most popular technology in the process type of industry. I think that's about it then. Again, thank you very much for attending. These are the contact details. Do connect with me. If you have any questions, that pops into your mind later on. So yeah, take the opportunity, scan that QR code, connect with me on LinkedIn, or shoot me a regular mail if you like. Thank you.